Sajeev John, a professor and Canada Research Chair in Optical Science at the University of Toronto, wins $1 million prize of Natural Science and Engineering Research of Canada. At first, he tried to figure out if it was possible to trap sound waves. Then he realized that doing the same thing with a light would be a big deal. I became curious about him and I went to his website at Toronto University webpage in the physics department. Here there are the selected publications from him, which is a start from 1984. And at the end you can see the selected publication from 2020 up to present. Let's look at his latest publication in 2021. So here it is the paper. It was published in Elsevier in the Journal of Solar Energy Materials and Solar Cells. First of all, let's go and look at the photonic crystals. Photonic crystals have the regular structure of natural crystals. They look a bit like cages. They are cages that trap photons, the particles of light that moves at 300,000 km per second. It is like putting fireflies in a jar. But in this scenario, instead of fireflies, we put electromagnetic wave inside the jar. For example, right now, an email messages leaves your computer as an electronic signal, gets converted to light, whatever it reach a fiber, to optic trunk line, and then gets converted back and forth again many times as it gets routed through the networks. If the net used photonic microchips, its speed and capacity could increase at least 100-fold. Nowadays, computers have electricity microprocessors. If we can do the same with light and replace this electricity with light, the optical computers will appear. These type of computers could process trillions of bits per second. That's thousands of times faster than nowadays computers. But as he said about his current research, the area that he most excited about right now is in using the concept of trapping light to trap light from the sun. His goal is to create thin, flexible, and high-efficiency solar cells by using this type of photonic crystals to trap light. John envisions such materials being applied to buildings, vehicles, and maybe even clothing, because these type of solar cells would be extremely lightweight.